Hi everyone. Thank you all for attending this presentation. Today's content were supposed to be shown last week at the Autodesk University during a Q&A session with Jean-François Villette, the November 18th following his class OLE BIM after 2 years of implementation for SNCF Réseau. Unfortunately, due to a lack of time and some platform issues, it has not been possible to show you this content, which is why we do it this way. This additional content is presented on November 18th, 2020, without any obligation to update it to reflect any circumstances that have evolved after that date. The statement presented in this document do not commit the decision-making choices that will be retained by the management of the BIM program. Planned or possible internal development effort may change without prior notification. This PowerPoint is not the same that we use in the BLD 466877 class movie, and it provides additional content. I'd also like to say to the French speaker attendees that the content exposed here is also available in French. Just refer to the BLD 466877 additional movie in PowerPoint. So, about the speakers, Jean-François Villette is a studies manager and BIM manager in the electric traction division attached to Nantes and Rennes engineering poles, and I, Béranger Marquez, is attached to Infrapole Paris Southwest. The Nantes and Rennes engineering pole is composed of several work fields. The general studies are the track, train platform, railway signaling, infrastructure, electric station, electric energy, and telecommunication. The class Jean-François realized was here to review BIM implementation within the electric traction in the Nantes-Rennes engineering pole. The first work was designing to create a model and phase it. Now, the idea is to emphasize the eye of BIM and attach the information in an efficient and reliable way. The idea is to transform data, regardless of its type or form, into something usable by everyone, the conceptors, the maintainer, or the operator. I also would like to point to a convergence with Jean-François' work and those carried out by the Hub Sector project. As a reminder, the Hub Sector project is the project which aims to produce a BIM model for maintenance for SNCF Réseau. During the A phase, various track bundles have been modeled with the GVZ station in order to provide maintainers with a vision of the railway components and the fault to be treated in the area, all connected to internal databases. You can read more about the project by viewing the Autodesk University class, Railway Maintenance Processes Automation, how to link BIM data to GIS model. At the moment, we are in the second phase of production with the objective of extending the project to the 30 kilometers of infrastructure that represent all of the maintenance sectors of GVZ, while including also more work fields such as including catenaries. This is for this reason that I have contacted Jean-François. Our two approaches have point of convergence, in particular on the cartography aspect of our respective projects. The idea with this convergence is to take advantage of a geographical area with a large opening porticos from our B phase, similar to the Le Mans Station project carried out by Jean-François, to standardize our processes. The method will be directed by infrastructure software such as Civil 3D. And the investigative work focuses on the integration of trade related to electric station and more particularly on the alphanumeric data carried by the assembly books. Although Jean-François' class being heavily Revit-oriented, it is important to say that the electric traction teams are being trained to use Civil 3D, which is a linear infrastructure tool. At present, there are two types of approach to modelize the catenaries. The one shown by Jean-François, a Revit-focused approach with the pro of having parametric catenaries, supports using mostly families. But concerning the track, Jean-François needs to base 3D static, non-dynamic, and non-parametric polylines. The second approach is Civil 3D and inventor-oriented, with the pro of using Civil for the modelization of the track. The support will be made in Inventor, but unfortunately, there are still technical boundaries preventing us from getting parametric support directly in Civil 3D. However, it is possible to make several IPT export, like Inventor assembly, to Civil 3D, but we will have as many blocks as we have configuration. For the electric traction study manager, it is not ideal, especially during a project phase or a catenaries reshuffle. Each approach has pros and cons, but this class will dig into the Civil 3D approach and what we expect from this software. When we elaborate this webinar support, the Infrastructure Designs Lab was to be announced. It is an online masterclass organized by Victoria Arena, technical specialist for Autodesk Spain, along with Wouter Belens, BIM manager for TuckRail in Belgium, and Justin Russell from Stantec USA. We were wondering if this presentation will be the answer to all of our questions. The answer to that is not necessarily yes, but the speaker brought very interesting customized content, answering a decent amount of our question about the joint use of Inventor Civil 3D. In the first part, Wouter Belens showed us how to make a tunnel become parametric, and how to deform section without having to use a guidance targets that we traditionally use to make a Civil 3D corridor. Wouter Belens went further using a JSON file that is referring to an Excel file using mathematics formula to create shape out of the box and thus create new functions that are not natively within the software. It allows a tunnel to become parametrics. Justin Rasleys went deeper into the concept using a tunnel section. He decomposed the tunnel into 3 configuration cases in the subassembly composer: a simple tunnel, a junction with an ovoid section, and 2 tunnels. The goal being to represent the model of a turnout. With Dynamo and custom Python scripts, Justin has been able to segment a 3D project in multiple zones and bring the parameters of the subassembly composer into a parameter table in Inventor. Justin is able to remodel areas of the Civil 3D project in Inventor, then implement parametric objects such as signalization panels, and to bring back those panels into Civil as blocks. The goal is to know if at last we could bring back either IAM assembly Inventor to Civil 3D, which seems possible according to the speakers with complementary development. It is interesting to see that Justin Rassley and Wouter Belens, due to their high level of knowledge in the software, are able to bypass the boundaries to develop functions that are awaited natively in Civil 3D, using tools in the AEC and manufacturing collection. I invite you to watch this class through the replay available in the Autodesk University channel. Given that at present there is no solution that can meet all the need, whether one uses either Revit or the Civil 3D Inventor Association, we can legitimately ask ourselves about the hybridization between platforms. What about the complementary development of Civil Connection? The first question to ask yourself is, what is Civil Connection? This is a complementary packaging for Dynamo for Revit and only for the Revit version, not Civil 3D. The initial objective of this packaging is to be able to interpret projects from Autodesk Civil 3D in Autodesk Revit to finish the model authoring part in Revit. We use a reference infrastructure, for example a road, a highway, or a railroad, and we then model the equipment. The problem with this solution is that it is not integrated into the official Autodesk product roadmap. It is a hybrid solution developed by consulting and it's independent of the product line. Its maintenance is also linked to the good survival of the post-sale service, and in this case, the CSO, Customer Success Organization. If you have looked at Autodesk University Las Vegas 2019 classes, some engineering firms like Dar al-Handasa have tried this workflow before but applied to civil engineering structures. Engineers have used it on structure because the cross-section is constant. They first model the horizontal axis of the road, determined by the long project profile, build the corridor in Civil 3D, and then carried out the civil engineering part specific to the structure in Revit. The solution can meet the needs in the case of constant cross-section, but this is only very rarely the case for railway uses. Platforms, turnout areas, connections, it all has variable width and different sections. Another topic that is important with Revit is georeferencing. Today, we no longer just make parametric models in Revit, we also address the geographic context. It has become essential to deal with the connection between BIM and GIS. That is to say that whatever the infrastructure and its project phase, design, or construction, the environment must be taken into account. There are several types of 3D GIS proprietary or open source formats. Autodesk has teamed up with S3 to enable native connectivity, but we also talk about the free format later in this class, like GeoPackage or TTGML. We recommend that you pay attention to the CEO topic with Autodesk Revit, as you might face a number of issues when putting pieces of Cartesian digital mockup together. Geomatics is a particular discipline that takes into account the geodetic aspect of project and geographic reference system, and projects and systems must be concept mastered by engineers. In his class in French, Jean-François broached the very important subject of the treatment of point clouds. Regarding the processing of breakline on InfraWorks, it is now no longer necessary to directly use RigRap Pro desktop to process them upstream. Requires at least InfraWorks 2021. InfraWorks can now recover .las LiDAR aerial survey files, but not .laz or ZLAS variants. What Autodesk doesn't say directly, however, is that InfraWorks continue to turn them into recap caches .rcs/.rcp for use. For the moment, only the software mentioned above, Cyclone 3D and ArcGIS Pro, know how to directly exploit clouds by taking them as they are and without having to perform intermediate processing operation. If today InfraWorks is already able to use an automatic extraction function, it does not yet meet our needs for a railway application. Difficulties in processing the track when the cloud is not dense enough, and this is always more or less the case with the Regal mobile capture section fixed on the rolling track, and impossible to generate the 3D polyline associated with the contact wires and catenary wire support, main or auxiliary. On the other hand, it works well for detecting paint on the ground or borders, and over time, the characteristic line attach more and more to the previously generated InfraWorks terrain. The SNCF North-Red Perry is fortunate to be equipped with Cyclone 3DR software, which is part of the Leica portfolio, which is part of the American group. Cyclone 3DR is a new trade name for the old 3D Reshaper software. Autodesk is now working with Leica as we see a move away from Autodesk tablet products in favor of new Leica solution. In addition, there is a phenomenon that is still little talked about, and that is the rise of Esri Group, which is also an Autodesk partner on the subject of the machine learning and deep learning. The publisher announced at the French SIG 2020 conference that their flagship tool, ArcGIS Pro, intend to address this data processing topic with a new .dlpk deep learning package file format. Esri want to keep developing as quickly as possible. They already offer satellite imagery function and are now looking at photogrammetry and lasergrammetry technologies. However, what interests us with reality capture are in particular the processing of later point cloud, and Esri is moving toward this field by proposing additional development. These still remain a purely code look, but the functionality is naturally dissolving into the ArcGIS Pro interface to be less off-putting to program users. The .dlpk file should be trained to automate the search for real feature and eventually will be able to extract feature line naturally. Currently, this process is very time-consuming, and this new feature will help avoid manual processing, bringing additional convenience to the research worker. We are currently looking to make the most of point clouds and in particular the automatic detection of objects inside. Different products give the possibility of extracting the conductors in the form of 3D polylines as long as the cloud is of sufficiently good quality. This polyline gives us a lot of information. Simple script can detect the eye point and find the coordinates of the ellipses, and therefore deduce part of the picket. This gives the possibility, for example, of implanting the object in the model in a semi-automatic way. By integrating the polyline of the rail, it is also possible to highlight the geometry of the contact plane, the height of the contact wires, and its offset. We can also imagine detecting blue areas where the contact plane is less than 5 meters high, for which certain precaution must be taken. It is also possible to associate this data with the long track profiles to work more efficiently during track geometry adjustment work. While working with Jean-François, we realized that one of his main expectations was the study of longitudinal profiles dedicated to the catenary contact wire. It should be noted that the Civil 3D Rail model recently added the notion of rail count, 2021.1 release. If you look closely to the image at the bottom left, in the red frame, we end up with an additional band dedicated to the track, and moreover, whilst graphic charter is still based on the US style and not fully integrated into the display proposed by the country kit France. Indeed, in Europe, the project and contracting authorities take care of the paper deliverables, which are ultra detailed with regard to what can be done in USA, for example. On a dataset, we tested what we could obtain as a result for studies of longitudinal profile dedicated to the catenaries. We duplicated a style to add two bends to it. The first interprets the projection of a contact wire in its vertical profile, and the second makes the difference between the altimetry of the contact wire and the average running plane of the rail, especially not to take into account the natural terrain. If the track plane is updated, and this is still the case after on-site operations, such as skidding or a track renewal with heavy mechanical tamping, the age differences are automatically recalculated by the software. If the alphanumeric data is exported automatically using Dynamo, the script will rephrase the content. This advanced feature of CV3D appealed to electric traction teams. To complete their studies, we could even consider designing a second catenary style with yet other additional bands, altimetric differences between the contact wire and the two rows of rails, for example. All of this data should make life easier for the operators in charge of production. And there, a new topic arrives. It is the appearance of dedicated catenary content in Autodesk CV3D, which until now was rather reserved for permanent way use. The software could also provide additional deliverables to maintainers, ones that are not currently available or impossible to generate with software such as Revit. Today, SNCF rather uses Excel files on site, but unfortunately, without necessarily having a geometric representation of where the defect or characteristic point is located. With CV3D, divide your screen into two windows, and when you move your cursor over a longitudinal profile, a dynamic cross simultaneously sweeps the horizontal axis over the associated kilometer point and vice versa. In this part, we'll talk about SETVF, the Union of Railway Contractors. An initiative was recently launched by Xavier Grovut, ETF Technical Director, and Pascal Delaurence, ETF CEO, to set up a mission to harmonize BIM tools and uses, particularly on the catenary topic. In the profession in France, this is a historic thing because entrepreneurs have never seated themselves around a table to discuss thematic municipalities in the study phases. Each actor has developed his application profession in his corner. With the arrival of large software portfolios, the cards are redistributed in the profession. Today, this player who wants to master the business needs to find the best way to transit to digital methods. Here, we have tried to list in the blue boxes the majority of contractors who know how to do catenaries. But they are not all there. For example, MyRail, which is a small company. Consultancies and engineering company have also been included in orange frames on the right. Idem, the list is not exhaustive. It lacks CSC, which is based in Nantes, and Sotec, which is a subsidiary of Cetec. In addition, a number of freelancers and self-employed people are isolated, but are well contracted out by some of these companies to perform some tasks and make some plans. For now, the field of contractors around the table is still limited. There is SNCF Réseau, the infrastructure owner, the Union of ETF, Vinci Group, COSRI, Brick Group, TSO, NG Group, and C2F, Unifer Group. As you can see in the slide that appears, this is actually only a part of the actors. On the consultancy side, Cetec is already discussing with SNCF following Jean-François' Autodesk University class, and Sistra has in the past set up an OLE development based on CV3D, which seems interesting to us. We would like to get closer to the teams to discuss the use of this model on projects. Aegis, on the Grand Paris Express project, had needs relating to assembly book with CV3, which is a subject that we'll address a little later in this video. And there we realize that the needs always end up overlapping whatever the mission of the actor of the profession is. In the past, the environment was rather individualistic, and we see that the matters are starting to change a little bit, and we can say that things are going in the right direction. As stated at the start of this webinar, one of the initiatives we wanted to carry out with the B phase of the UpSector project is the integration of catenary data for maintainers. For this, we were interested in a well-defined region on the entire track layout. At the south of the Juvisy station, there is an area of porticos with large opening. In the end, it is a use case very similar to what Jean-François was able to deal with for the Le Mans station with Revit, and it is moreover for this expected that we approached him. The only difference is that rather than integrating a few key parameters on the catenary ports, we'll try to dump most of the content of the nomenclatures carried out by the views section. We ask ourselves the question of how to transcribe these alphanumeric data, which are at best carried out by an attribute and at worst by a decomposed text. The first notion to integrate is the concept of assembly book. We name it carnet de montage in France, and it is a very specific way to work, exclusively for SNCF business. You must not find this delivery overseas. By default, it seems linked to the section view, because it is including the section view at 100 scales, but it also includes the materials nomenclatures for quantity takeoff, QTO, and this alphanumeric data is more important than the only cross-section representation. Assembly books are deliverable, usually in A4 format, although they may be in A3 format for gantries or XA4 in station areas. The extra large sheet of paper will be folded as many times as necessary. The assembly sheets are a cross-section in line with the catenary support. Usually, when the supports are facing each other, there are 2 posts per board at a given section, but sometimes there is only 1 post per sheet in curves or spirals, for example. This deliverable is very important for maintenance because it indicates the assemblies or sub-assemblies that should be installed on site. Insulators, cantilevers, tie wire, steady arm, swivel, etc., etc. For each component, we have the designation, the sketch reference, the plans reference, and the number of equipment. All these data are important because of the overhead line is a technical niche. There are many technical reference systems, each one interdependent on the other, from a macroscopic view to a microscopic view, from the assembly to the subassembly to arrive up to the individual piece. For example, per section view sheet will have here 243 attributes to take into account, while in phase A of the project the device was turned out with only 35 maintenance attributes to take into account. It's 7 times lower ratio. Of course, it is out of question to manually copy 243 attributes in order to extract the alphanumeric data afterwards. It therefore seemed essential to us to create an initiative within SNCF for the use of this data, and also how to transmit it to construction companies, in particular through the SETVF group presented just before. The goal is to eventually create a section view template, which is standardized for all players in the profession, which is not the case for now. Each company has its own internal tool with its own section view torches, and we must review this process. For some companies, the templates are already well structured, and it will be easy for them to come and adapt their tool with a new template that the SNCF will impose. But for other companies that do not use templates and break down all the text, it will be more difficult to adhere to the method. For JVD, it was thought to work best and as quickly as possible. That is to say that initial results can be highlighted only with the use of the AutoCAD Map 3D and its geometric features. AutoCAD Map 3D can take into account file formats that are not taken into account by a traditional AutoCAD. For example, GIS files such as shapefile or special data file, CTGML 2D, etc., etc. In addition, AutoCAD Map 3D has more advanced features than AutoCAD, including connection to database or coming to perform queries on drawing. With these functionalities, it will be possible for us to transcribe the alphanumeric data carried by the nomenclatures of the assembly book to reuse it in our CV3D model. We insist on the fact that we are just going to work on the alphanumeric data here. Alphanumeric because the data is in fact a succession of strings of character or digit number for the quantification of the element installed on site. The cross-section you see in the section view is also data, but graphical data on a handress cut. For now, our goal is not to come and process this information as a priority. We'll talk about this a little later in the video. In JVC's context, the objective is only to get the alphanumeric data to transcribe it into another model authoring software, to be able to use it in the database, whether they are a vector or a row access type, and also formatted on the 2D GIS map. Here, we investigated on the work that will have to be put in place with the contractors to correctly use the alphanumeric data carried by the nomenclatures of the section views. The postulate is to set up a standardized section view template validated by the General Industrial and Electrical Traction Engineering Department, DG2ITE. Setting up a data channel where the attributes of the section view will be codified will allow the use of a two-way flow between SNCF and its subcontractors, so that everyone can emerge as a winner from the use of this alphanumeric data. SNCF is a manager of French assets, and its applications are as numerous as they are transversal. It is no longer possible to work with unstructured data. Internally, the SNCF has numerous repositories and data silos. Sometimes we have databases, sometimes data lakes. You can't build a workflow with sustainability over time if you don't set up a viable data exchange system. What is expected here is to lay down common foundation between the principal and his subcontractors at a store specific to each company, since in the end, the assembly book will be the same for everyone. It doesn't matter who would have carried out the work before the intervention of a company. The data can be used by everyone if it has been standardized upstream, and this is not yet the case. The technological level between the works company is disparate. Some works companies have more advanced management of their equipment part than others. For example, by using database management systems, and it will then be sufficient to make attributes mapping for a correlation between the data channel and their internal stores data. And others only use Excel spreadsheets, so it will simply be necessary to develop a VBA macro to do the conversion and restructure the data as they used it before. Or better, take advantage of this initiative so that this company can tackle the digital transition by setting up, for example, a database management system. For the moment, the alphanumeric data carried by the assembly book is not yet object-oriented. These are bits of information that will be dumped into a digital model with a few intermediate processing steps. Ultimately, we'll have to come and work on the definition of each object, but this is a subject still under discussion within the technical department of SNCF. For now, we're just trying to put in place a way to transcribe our string to BIM and GIS model by setting up a common channel and using AutoCAD Maps 3D with attribute tables. It is now essential to bring added value by setting up an efficient workflow. Now that we have tackled the subject of alphanumeric data present in the nomenclatures of assembly book, we are going to turn to the geometric content carried by the section views at the upper part. The section in line with the catenary supports are shown to the endlet. When a catenary beam model is produced, regardless of the software used, the level of detail is much higher than what could be done previously on AutoCAD representation. On the assembly book traditionally used by maintainers, the blocks represented are simplified elements to maintain readability in the field and to be able to interpret the insertion point of numerical dimension. For example, it is not necessary to have the complete level of detail of the insulators. A simple rectangle is sufficient for the representation. The advantage of Civil 3D over a Revit is its ability to take into account multi-view blocks, whose geometry definition varies depending the orientation. This is what you see in the blue circle at the bottom of the screen. For example, we try to have a circle with a console in top view, and simplify geometric representation for the left, right, front, and back views. In the 3D model in isometric view, we'll keep the level of detail established in the 3D inventor models. But the objective for us here is to have readable elements on the projection of section views to maintain continuity on work habits of maintainers on site. The workflow is simple. First, position the catenary support with Dynamo. Implement the Civil 3D section line at each station of catenary supports, and load an SNCF view section template to reconstitute an assembly book. The last point to be investigated is how to establish a dynamic and bidirectional link between the alphanumeric data carried by the nomenclatures and the representation of catenary supports in MVB. We have already performed some initial tests with object data, OD, but we're not yet satisfied with the results. Investigations are still to be carried out, and we hope to find an answer as soon as possible. The ultimate goal is, of course, to have an automatic solution by integrating definition of property sets on the fly to manage a large number of catenary supports. To ensure the proper execution of those rail projects, SNCF must have design elements enabling it to carry out its studies. Previously, we talked about the longitudinal profile studies for the catenary contact wire, and we noticed that it was still necessary to come and configure styles to be able to generate a deliverable. It is necessary to have beforehand styles of profile lines for electrical conductors, styles of strips for longitudinal profiles, with always the possibility of having anamorphic scales with regards to the vertical representation. Currently, the French ContiKit made available is very road application oriented and still lack content to carry out the railway studies. If we insert a template of section view into the ContiKit, we can also legitimately integrate the template for layout plans with dynamic title block. Going further, we could also review the XML files of railway standards for horizontal geometry, horizontal axis, and vertical geometry, design of the project long profile line, which have not been updated for France with the arrival of the Civil 3D rail model. Civil 3D did bring new features, for example, standards for the Chinese, German, Belgian, UK, and USA market, standards for docks, low, mid, high, but did not update all the French content. For GVC-B phase, we also deal with the subject of electrical protection zone, which involved generating deliverable with hatching for each zone. These points carried by track maintenance will later be studied for catenary design studies with Jean-François. It will be necessary to come and set up a set of styles codes. The question therefore arises, who should develop this content? Is it directly the SNCF? If so, with what budget, what workforce, for what time allocation? It would be the first time that additional content has been developed by third parties. For example, the Aegis Consultancies has its own business packaging and does not use the French ContiKit by default for these studies. On the contrary, is it rather the responsibility of the software publisher to address this point and integrate the content by default? In all cases, rail content is lacking in order to be able to process the catenary studies turnkey. We'll now discuss the topic of mapping and using 2D GIS, including leaflet technology and the Common Data Environment, CDE, Trimble Connect. In 2018, SNCF Réseau launched a call for tenders for software publishers concerning an experimentation phase relating to the establishment of a collaborative platform. Trimble won the market with its Trimble Connect web platform usable on-site on tablets and Trimble Query solution for internal database management. We investigated with Jean-François Trimble Connect for his GIS part. Unlike the collaborative platform of other editors, Trimble Connect directly integrates GIS module in addition to the traditional EDM approach. It seems like a good idea to see what could be done with this module. First, we came to integrate GIS layer of the National Rail Network in shapefile format to judge the behavior of the tool. Then we ask ourselves the question of a comparison between Trimble Connect and the internal DGII data lake used by SNCF. If you watch Jean-François' class in France, you will see that the internal platform allows him to come and map his catenary support by integrating some information from a .txt or CSV text format. To go further, we wonder if there was an interest for maintainers to have in the field a simplified representation of assets using 2D mapping. 2D because Trimble Connect doesn't take into account the 3D mapping, unlike S3, which has made great breakthrough in this subject. Of course, the objective will be to also be able to have access to the alphanumeric data carried by the nomenclature of the assembly book by clicking on each catenary support symbol. When we performed the first test, we found that Trimble GIS module used leaflet technology. So, what is leaflet? Leaflet is an open source library also used by the OpenStreetMap project, and it allows Trimble Connect to load register files, which are in the process the same as those loaded internally by the data lake from the GGII. The most interesting thing is that Leaflet supports a free API from S3, which will allow it to load from the geodatabase, which remain a proprietary format. Pay attention, we are talking about a two-dimensional format because 3D GDB is not supported. Moreover, it is not possible to integrate a geodatabase greater than 40 megabits with Trimble Connect. Why promote Trimble Connect? Quite simply because of the management of access rights and user. Not only the SNCF employees, but also its partners and contractors who intervene on site. Part of this was shown earlier in the video when we were talking about the Union of Railway Contractors. We now ask ourselves, what could we put in place with the management of rights, and especially for the management of the team who have to go into the field? Do we share all of the data? If not, what are we sharing? How will this new tool be interpreted by construction companies? Are they at least equipped with on-site tablets? Does the initiative appeal, if so, with SNCF or contractors? What is the added value? Can we do without paper on site? Do we save time on information processing? Are we going to save time on the production of proof? Do we gain productivity on site? Many questions are put on the table, and we hope to be able to set up a common data environment on a technical matter to judge the potential. In addition to the purely cartographic aspect in 2D GIS, we keep carrying out investigation on 3D GIS. On the A phase of the Geodesys project, infrastructure winner of the 2020 Goddard BIM Award in France, we use the BIM-GIS connection relative to Autodesk product to the S3 ecosystem. The ETL FME workbench was used to transcribe the infrastructure data from Civil 3D to ArcGIS Pro, and then to ArcGIS Online. Since then, we still continue to work with this ETL edited by the Canadian company Safe Software, but this time we wonder how to come up with an alternative to the proprietary .gdb geodatabase format for the benefit of open source formats. At first, we heard about the GeoPackage format, which is often described as free format competing with S3 shapefile. It was while doing tests on QGIS that we realized that it was possible to process 3D scenes with these formats, so we started doing documentary research on it. GeoPackage is a format on the OGC, Open Geospatial Consortium, and it seems promising because it is based on the SQLite structure like InfraWorks. We had ideas for work and therefore began to draw up certain hypotheses to develop workflows. First of all, we realized that everything that revolved around Civil 3D model authoring had to remain internally at SNCF Réseau. This notably includes maintenance databases, but also Dynamo scripts that automate the placement of POIs and dump the data on them. This expertise must be kept by the principal and does not have to be communicated to third party. Civil 3D models produced can be exported to IFC for viewing in Trimble Connect by consistencies and engineering partners. The traditional deliverables generated by Civil 3D, layout plan, vertical profiles, section views, etc., can be communicated without fear. They do not integrate the parametric design files with the corridor. The ETL FME workbench was then to be used to convert the parametric Civil 3D model to the GeoPackage formats. The question arose as to whether this file format was linked to InfraWorks models for contractors. The first image you see is a screenshot of an InfraWorks model builder. As a reminder, Model Builder is a wizard that allows you to quickly have a three-dimensional model of a site when there is no input data. This is a process that is very interesting for projects in the upstream phase, but its use is more limited to the design or operation phase. About what you see on screen, let's be honest, the track geometry is not suitable for proper use on the model. Just as a reminder, the InfraWorks Model Builder uses three data sources. NASA's GNSS sources are what make it possible to model terrain, which is in fact a mesh. On this ground, we come to apply our Microsoft Bing base map, which is the publisher with a framework contract with Autodesk. Then only after that we come to display OSMS content for the display of roads, railroads, river, float, building, etc. The idea we had with the GeoPackage format was what we can see in the second screenshot. The objective was to be able to transmit to contractor part of a digital model or an entire railway sector instead of the previous model generated by Model Builder. The GeoPackage formats and the InfraWorks model being based on SQLite, it will have been interesting to come and build a bridge between these two solutions. The elements that we could have been transmitted concern only the geometry, but a reliable geometry and without transmitting the alphanumeric data of the maintenance, which remain internally in SNCF, point of interest, numbers of days remaining before intervention, etc. A way should have been found to make these elements available to replace the official model builder by an SNCF portal, for example based on Forge technology, where companies actually download 3D solids from 3D projects. SNCF then kept control of the parametric content, Civil 3D master files, as well as its dynamo scripts, and the contractors add a solid base of representation of the rail networks. For catenary scales for tenders, it could have been interesting to offer phasing, intervention variants, or site preparation, for example. We must not forget that the catenary in a project is a trade which represents only 1/10 of the total cost of the track. However, the JVC project being basically a track maintenance project, it was the right time to prepare for the integration of other trades. Unfortunately, all hopes have been dashed for one reason. The GeoPackage format allows editing of 3D scenes, but what we did not yet know is that, like the chep file, it is not native 3D object-oriented file. In fact, to generate 3D scenes, it extrudes a footprint according to 8th attitude. The only credible alternative to SWI's geodatabase is the CTGML format, which is natively oriented to 3D objects. The new question to ask yourself is, what is a CTGML? Like GeoPackage, it is also an OGC standard, and we also know how to work on it with an ETL. During phase A of the GVSys project, we had succeeded in transcribing the Civil 3D model into the geodatabase format, and this time, for phase B, we wonder if the transcription was possible to the .gml file format. The answer is yes. In any case, the result is functional for civil engineering structures presented to you on screen. We started doing some documentary research to find out which viewer will be able to interpret CTGML, and we selected 6. 3 are in desktop application mode. IFBIM, a beta viewer of CSTB, French organism, FZK viewer, University Program of Karlsruhe German Institute, and 2Dcon CT Discover Lite. The fourth tool is an aggregation software, Navisworks. The last 2 products are common data environments, BIM360 and Trimble Connect. Before moving on the next slide, we insist on the fact that the first test only concerned the civil engineering structures of phase A, and not yet the modeling of the railway following the short time granted to the investigation. We have noticed that CTGML is a complex file format, unlike an IFC where we are still waiting for the arrival of different classes dedicated to infrastructures. CTGML is much more mature. Geographical information system is in existing science since 30 years or so, and there's been a lot of work done vis-à-vis the OGC. And this is something that is not yet found on the side of Building Smart International Association for IFC. In fact, we'll talk a little later about the potential of connection that there could be between CTGML and IFC. Here, for our test, we didn't succeed in the CTGML export on the first try. We had to fumble around and take an interest in multiple classes dedicated to bridges. The bridges class didn't work, neither the part bridge class, so we had to go through a generic object class related to bridges to get the results we'll show you on the next slide. 2 good students for this test are IFBIM from CSTB and FZK Viewer from Karlsruhe Institute of Technology, KIT. There is still a small advantage for FZK, which takes into account the colorimetry and which remains more ergonomic in use than its French counterpart. City Discoverer, which had given satisfaction on an open dataset from the Greater Lyon metropolitan area, unfortunately failed to interpret our export for the JVC bridge. Do not rely on the rendering on the screen with the church and its neighborhood. It is just the home interface of the software. Regarding Navisworks, it was not able to open the .gml format, but we already knew this because of the technical documentation of the product not indicating the inclusion of CTGML. Regarding the 2 common data environments, BIM360 and Trimble, the EDM detects the file but are not able to open it. Since you can't use the GeoPackage format, you wonder what to do with CTGML. Yes, it is a credible alternative, but what exactly to do with it? In the end, we noticed that there are quite a few viewers who know how to interpret it, and in France, the use of this file format is not really widespread. Should we eventually open CTGML with a proprietary web platform, maintenance-oriented supervision or hypervision software, Rhino Tarrant that we haven't tested yet, or is it just reduced to a GIS archive link from IFC files? At the moment, we are not yet in a position to answer this question, and it will be up to the BIM program to give the guideline on which to orient. In any case, if you need to export Civil 3D models to CTGML, you must use an ETL, here FME Workbench. The AutoCAD BAP 3D engine, included in Civil 3D, allows CTGML exports to be performed, but only for 2D objects, so it will not be able to process digital model produced by Civil 3D. In the end, these CTGML exports allow a little of interest if we want to transcribe it in InfraWorks or in the S3 ecosystem, because it is not natively supported by S3 software like ArcGIS Pro and Autodesk software. In both cases, you have to use an FME brick to bring it back into this software. For InfraWorks, we will use CTGML importer for InfraWorks, edited by SF software, and for ArcGIS Pro, we will use data interoperability for ArcGIS, which is also published by SF software. This amounts to performing a modulation operation with FME Workbench, then demodulation using an FME brick, while it is natively possible to export the Civil 3D corridor to InfraWorks or to use the S3 connector to send to ArcGIS Online. Admittedly, to transcribe a Civil 3D model with property sets in ArcGIS Pro, it is still necessary to use an ETL, but we will then speak of pseudo-native connection. There is no point in going through CTGML to communicate between the Autodesk and S3 portfolios, since the conversion has progressed well since the signing of the partnerships in 2017 between the two publishers. In the end, we still haven't found an answer to our question, okay to use CTGML, but what are we going to do with it? In Germany, there is a big step forward on GIS data in the open source CTGML format, which we don't really have yet in France. The railway principle, Dutch BAN, German equivalent of SNCF, requires its partner, mainly German consistencies, to find a bridge between IFC and CTGML. We try to perform a similar test with the ETL FME Workbench. To be honest, it is quite difficult to experiment on this subject because you already need to have CTGML input data, and apart from the open data of Grand Lion, there is little accessible. Besides, we only made one conversion attempt, CTGML to IFC, and it wasn't successful. For now, determining a workflow between these two file formats is not yet the priority, but it is something to keep in mind. The subject of connection between two free formats remains complicated. Based on our knowledge, and apart from the Germans, we do not know anyone who works on this subject, at least in Europe. And it is difficult to have feedback, especially since the reference organizations are not the same. OGC for CTGML, OpenGIS, and Building Smart International for IFC, OpenBIM. In any case, we have become aware of the importance of this theme, allowing information to dialogue between these two free formats, and it is likely that this subject will be the logical continuation of BIM-GIS connection as soon as it will be natively integrated by the editor in the software. A lot of standardization has to be done, and work is still in progress between the proprietary format Autodesk and S3. Then we look at open source formats afterwards. In addition to the investigation carried out on the BIM-GIS connection with free formats, we're still looking at what can be done with the S3 ecosystem with the joint use of ETL FME and ArcGIS Pro. The transcription of Civil 3D models to ArcGIS Pro is now a mastered workflow. This is the image you see at the top left, the one which was widely used by the press in communication to announce the winner of the infrastructure category of the Golden BIM Award in France. Initially, we had worked with ArcGIS Pro 2.5, which at the time did not allow natively reading .dwg file. And we had to use FME Workbench to transcribe the Civil 3D geometry and property sets into ArcGIS Pro attribute tables. Since the version 2.6 of ArcGIS Pro was released, it can natively read the DWG formats, with still some gaps in the interpretation of colorimetry and still this inability to interpret Civil 3D property sets. But whatever arrives with FME, we know how to put an infrastructure project into its geographical context, 3D solids from a corridor or point of interest in block reference position on the fly by using Dynamo. So, if S3 is able to aggregate data that come from Autodesk ecosystem, we can also legitimately ask the question of the ecosystem of other software publishers. Regarding Bentley's solution, we did some documentary research on this and we learned that SNTB USA Engineering have found functional results. On our side, we have not carried out any investigative works. That is to say that we did not use Bentley's model to transcribe them with FME Workbench, and besides, we do not even know if it has already been done in France. What we know is that SNTB has managed to hold the same workflow with FME Workbench as we did with the Autodesk ecosystem, and that their engineers are able to transcribe the geometry and alphanumeric data to ArcGIS Enterprise. They choose to transcribe their civil engineering structures in ArcGIS Enterprise to simulate the construction phasings, to dispense themselves with the Navisworks equivalent at Bentley in 4D phase, and to use their own internal timeliner. Please note that setting up a similar ArcGIS Enterprise model requires a lot more IT and development knowledge than a simple transcription to ArcGIS Pro as we did. Either way, the solution is functional, and this shows the potential of S3 solution to become platforms for the integration and exploitation of data, regardless of the department or the publisher who helped creating them. So, for the specific Franco-French market, we also wonder what we could be doing on the GeoMedia solution. The first question that participants who do not live in France or Belgium will ask themselves is, what is GeoMedia? The true question might not be what, but rather who. GeoMedia is a French company which belongs to the Geodesiel Group. Geodesiel Group was founded at the end of 2016, following the merger of the Geomensura SAS and GeoMedia SAS. These two brands have been recognized by professionals for more than 40 years on the French market for geomatic engineering, town planning, landscaping, and transport infrastructures engineering. If you do not live in France or a French-speaking country, there is little chance that you have used GeoMedia solution, Covadis or Autopist, which uses an AutoCAD engine to operate. These solutions are not available in English. On the other hand, Mensura Genius, published by Geomensura, the other solution of the group, is a product available in English but which is not based on an AutoCAD engine. We'd like to thank Lionel Perrin for providing us with the example datasets. This is a part of the T6 tram line in Lyon. Covadis projects mainly use ACAD proxy entities type object, and we were interested in the transcription of this object into the 3D GIS of ArcGIS Pro. We had two approaches. Use ArcGIS Pro 2.5 and keep the same workflows that has already been applied with FME and Civil 3D for the phase A of GVZ, image on the left, or directly interpret the .dwg file in ArcGIS Pro 2.6 without ETL, image at the right, and see the behavior of the S3 product. For the first configuration case, ArcGIS Pro 2.5 using the ETL FME workbench, there is significant cleaning work to be done upstream. The design with Covadis differs slightly from what can be done with Civil 3D. For example, implementing sample line is mandatory to build the Covadis project, while with Civil 3D, we do it afterwards, because the Covadis sample line are in fact Civil 3D frequencies. In addition, Covadis objects are not as smart as Civil 3D objects, so you have to isolate them, hide them, or even purge some of the AutoCAD layer. Covadis works on a traditional AutoCAD, so it is limited to the type of objects offered by the latter. Although, it is recommended to install Covadis on at last an AutoCAD Map 3D. We'll see why a little later. We did two tests to work with ArcGIS Pro 2.5. Break down all the ACAD proxy entities and then only simple AutoCAD elements remains. No problem to transcribe all with the FME workbench to ArcGIS Pro. Or to keep the ACAD proxies entities from the Covadis projects, and we realize that it's also possible to process them with FME, provided that only the initial geometry has been kept upstream. On the image you see on the left, we did not transcribe all of the networks because the upstream cleaning work was really taking a long time. So we really limited ourselves to a small selection of objects, but it is sufficient for the first try. We'll try to write a methodological note for Q1 2021 in order to leave internal traceability of our investigative work, but for the moment, this is not the priority. We'll come back to the subject of alphanumeric data later. The problem is anyway common to both configurations, whether using ArcGIS Pro 2.5 with ETL or ArcGIS Pro 2.6 without ETL. For the second configuration case, that is to say a native interpretation of the DWG format, we just drag and drop the file in the S3 software. The result is the one shown in the image on the right. We realize that everything that will be point object, such as the candelabra, information post, etc., appears as POEs tackled to the ground, and this is roughly the same result that we have with an interpretation of the Civil 3D design. However, with OptiTL, it is always complicated to have a perfect transcription of the geometry presented in the input data, and even if ArcGIS 2.6 can natively read DWG file, we recommend using FME Workbench to do this in thought of transcribing the Covadis model into an history geodatabase. This is the best way to obtain a correct result in 3D GIS. The only big difference between Civil 3D and Covadis about ArcGIS Pro 2.6 is that Civil 3D TIN surfaces are recognized directly by S3 software, and it adapts to the terrain accordingly. For users of GeoMedia solutions, it is necessary to transcribe the ACADE proxy entity mesh in a geodatabase using FME, which will have to process the triangle one by one. It is very long. It consumes a lot of RAM, at least prefers 64 gigs of RAM, and that will be a problem on the large area. Regarding alphanumeric data, this is probably the weak point of GeoMedra's solution. With Civil 3D, the information is carried by the property set and the object themselves. For the corridor, property set are integrated by default, but it's quite possible to customize property set on any type of object, Civil 3D or AutoCAD. For the alphanumeric data part, GeoMedia has chosen to import and export information on the fly using raw text file, type .txt or CSV, using proprietary dialog boxes which are only compatible with their solution. They do not go through features included in the API of Autodesk software that acts as hosts. However, there are many customers in France who make the mistake of connecting a Covadis or an Autopist directly to a simple AutoCAD. To correctly design a linear project, it is necessary to use at least an AutoCAD Map 3D, which allows to take into account the georeferencing projection system and to make GIS requests or on CAD drawing. Customers who are going to use Covadis on a simple AutoCAD are going to have problems because they cannot associate the complementary alphanumeric data on objects. AutoCAD Map 3D at least alleviates this problem by using object data, OD, which are GIS functionalities that cannot be interpreted by a simple AutoCAD. In addition, FME knows how to interpret this object data, so de facto we can come and transcribe it in ArcGIS Pro, even if we do not have Civil 3D. We could also use a Covadis connected to Autodesk Civil 3D to associate this external data in property sets. To do an IFC export correctly, it is necessary to benefit from a Map 3D engine. So if there was only one thing to remember, make sure you have at least an AutoCAD Map 3D. Without this, making a transcription in 3D GIS is going to be a dangerous operation. Revit already has integration problems due to its Cartesian coordinate system and inability to properly handle projection systems. And traditional AutoCAD has the same shortcoming. An infrastructure project must know how to take into account the geodesic aspect for insertion in the geographical context, and this will only work if you use at least AutoCAD Map 3D. In this case, you might be able to keep the geometry, but not the alphanumeric data. If no alphanumeric data to transcribe, no information in the attribute tables, and you will not get use of GIS, which will be a real shame. The last point of that rule on the additional content is the relationship that the SNCF Réseau principle may have with its external service providers, in particular contractors. There is a subject that we have been working about for many months with Jean-François, and that is how to integrate the BIM approach for the tender phase. Today, in SNCF specification, which are sent to the contractors, there are two options. Either there is no BIM clauses, either there is one that is half of the page at best. With Jean-François, we were wondering how to come and try to translate external documentation, in this case the open source documentation of Rail Baltica. For information, Rail Baltica is a rail network project in the Baltic countries, Poland, Lithuania, Latvia, Estonia, and then eventually connection to Finland. The Rail Baltica organization, which is the project owner, called on the American consultancies ICOM for project management assistance on the BIM parts. And it was the Spanish office in Madrid that was mandated to carry out this mission. The ICOM team worked on drafting the BIM charter, BIM protocol, BIM specification, and all the deliverables shown on the slide on the screen. You will find a link below to download all the documents. Access is free, the documents are copyright free, and it will be a shame not to do without. With Jean-François, the first thing that we must do is how to go through this documentation without drowning in it. Target the potentially interesting points to include them in the long term in a call for tenders. and then translate them to make so that they adapt to the French standards used by SNCF. We're not gonna lie, this is a job that will take time. Analysis time, translation time, finishing time, and finally, time to get the approval of the BIM program. On the other hand, it is an essential job to set in motion the contractors who are not really reactive and who must develop skills in new technologies to carry out studies differently, and not only as this company could do before on a traditional AutoCAD. For the moment in France, contractors do not have a legal obligation to position themselves on BIM, and our country is lagging behind what the United Kingdom or the Nordic countries can already do. In public procurement, even Italy is getting ahead of us in implementing BIM. In the course of 2021, we hope at least to be able to put in place a version, even incomplete, of a specification to encourage service providers to progress in their digital transition. This webinar featuring additional content concludes. Jean-François had quite elegantly mentioned at the end of his Autodesk University class in French that we were only at the start of the digital transition and Industry 4.0. And we're sure that is the case. Throughout this video, we covered a significant number of subjects, and in a way, maybe that's the problem. We just over them. There are still many others to investigate. Finally, if you have not had the opportunity to watch class in English and relating to Phase A of the Subsector project, we invite you to watch it. It concerns the implementation of the BIM maintenance process for the railway part at Juvisy Station. Consistent work in the transcription of the Civil 3D Model to ArcGIS Pro implementation of property sets with Dynamo from SNCF database exports and conservation of alphanumeric data in GIS attribute tables. We also would like to thank Philippe Bonneau, Technical Marketing Manager at Autodesk France, who supported us for the development of 4 video presentations with Jean-François Villette. Then for the organization of the Q&A live session in French specific to the class of Jean-François. If you have any question, do not hesitate to contact us directly for more information. Thank you for your presence.